Today's video is over classifying matter, and we're going to be looking at classifying matter into three main groups: elements, compounds, and mixtures. Please make sure that you have your student copy of your notes open, your Google Slides, and that you're filling them in as you're watching the video. After you have completed the independent slides, please submit your slides in Google Classroom. Matter. Matter, the definition of matter is anything that has mass and takes up space. So that's referring to its volume. Mass, what is actually mass, is how much you have of your substance, and it's not going to be affected by temperature or location. So that's where we're referring to weight. Weight is going to be affected by gravity, and that's why you can be weightless when you're in space. So that's your location. So I mentioned that matter can be classified into three main groups. We have elements, compounds, and mixtures. And we're going to go a little bit more into two different types of mixtures in our slide. So pure substances. Pure substances are going to be samples of matter that have definite chemical and physical properties. So that would be an example of elements and compounds. They're considered to be pure substances. Elements are going to be pure substances that cannot be broken down into simpler substances through chemical or physical means. Okay, so an element is going to be your simplest form of matter. Yes, I know that elements or atoms can be broken down into subatomic particles, protons, electrons, and neutrons. But what we're talking about is that's how you can identify them, that we're talking about chemical and physical means. Okay, so elements are your simplest form of matter. Compounds are going to be pure substances that are composed of two or more different elements that are chemically combined together or chemically bonded together. Compounds are going to have a specific ratio. So every molecule of water will have two hydrogen and one oxygen. Every molecule of carbon dioxide will have the ratio of one carbon to two oxygen. Also, you're going to think of compounds as having chemical formulas. They're going to be made up of several elements put together. So in this case, we have with water, hydrogen and oxygen. With salt or sodium chloride, we have the sodium element and the chloride element. And compounds can be broken down by chemical means back into their elements, but this is not done physically. It is done chemically. It's not a physical change, it's a chemical change. Mixtures are going to be a combination of two or more pure substances that are not chemically combined. So these mixtures can be a combination of two solids, two liquids, a solid and a liquid, where the solid is dissolved in the liquid. It can be two gases. So it doesn't necessarily have to be the same phase of matter, they can be different phases of matter. And one thing you need to note with mixtures is that they are being held together by physical forces. They're not chemically bonded together. So we're looking at phase changes here, not chemical changes. Each of your substance that makes up your mixture is going to keep its properties in that mixture. So if you add sugar to water, you can still taste the sugar that's been dissolved in the water. And they are going to be physically combined. So if we look at some physical changes here, we have the block. The block can be crushed into dust. These are all physical properties because of the fact that we haven't changed the chemical makeup of the block. It still has the same chemical and physical properties. It still has the same melting point, boiling point, is what I'm meaning by properties. Then we can melt the rock and then we can separate it, or excuse me, melt the block, and then we can separate it into its parts that make up that block. Tap water, like I mentioned, that we have the distillers in the lab. We can heat up that water, distill it, and remove the ions where you just have the water and the metal ions have been removed. You can also use filtration methods where you're using a funnel and paper, and you can separate a liquid from a solid. So that way you have the solid that's left behind on the filter paper in the funnel, and the liquid has gone through. So gravitational filtration is an example of a physical change. Boiling. So if we have salt in water, we can boil the water, and the salt would be left behind once all of the water has been boiled. So there's lots of different physical means that you can go through. Chromatography, where you separate different inks. By having the inks travel up the paper with a solvent. That's physical changes. If you have two liquids with distillation, what you can do with liquids is one of the liquids will have a lower boiling point than the other, so it will evaporate and go through a condenser. As it goes through its gas phase, the condenser is going to allow it to cool back down, and then it goes into a liquid in another container. So these are just all physical ways to separate mixtures. Mixtures versus compounds. So first off, mixtures, their composition is going to vary. They are not going to have the same amount, whereas a compound is going to have a definite composition. It's going to have a different ratio of elements, okay? It's not going to vary from each molecule that you have of a compound. Mixtures, if we're talking about if they're joined or not, they are not chemically combined or joined together or bonded, but compounds are chemically bonded together or chemically joined together within their elements. Properties, as far as a mixture, mixtures are going to keep their properties. Okay, so they're going to keep their melting point, their boiling point, their taste. They're going to keep those properties. Unlike a compound, those properties are going to change. So a great example I can give you is we know oxygen and hydrogen are both gases at room temperature. We know that oxygen is a flammable gas. Is a flammable gas and promotes burning. We also know that hydrogen is a flammable gas. But when they chemically combine together at room temperature, they make water, and water is a liquid at room temperature. Water does not promote burning if we're just talking about burning paper or wood. It's a clear liquid, whereas a gas is, or water vapor is a clear gas. So that's a really good example of how those chemical and physical properties have changed from the element form to where they chemically combine to form a compound. Mixtures, I mentioned that they can be separated through physical means, and I described several different physical means. As you know, as far as separating them out. A compound, you have to actually go through a chemical reaction to break them back down into their elements that make them up. Okay. So an example I have of mixtures would be air, seawater, most of your rocks are, whereas compounds would be like pure water, like distilled water, carbon dioxide, magnesium oxide, sodium chloride. So notice that you can almost see that, okay, carbon and dioxide, oxide is referring to oxygen. So I have two elements that I'm seeing in the name here. So I know that's a compound. Sodium chloride. Well, there is an element called chloride. It's that ion, just like oxide is the ion of oxygen, we're referring to the chloride ion, or the chlorine, the atom. So again, that is a compound. So we have two types of mixtures. We have a homogeneous mixture and we have a heterogeneous mixture. Homogeneous mixtures are going to be the same throughout. They have uniform characteristics. So any two samples that you take of that mixture will be exactly the same. So like coffee, milk, um, air. Those are all examples of homogeneous mixtures. Kool-Aid, sugar water, salt water, as long as it's not saturated where you put too much in and you can still see some of it in the bottom, but you put enough in so it's dissolved. Those are all examples of homogeneous mixtures, that they're the same and you can taste and they keep their chemical and physical properties. Heterogeneous mixtures, on the other hand, they are going to have different compositions. So any two samples that you take of a heterogeneous mixture will not be the same. So dirt, if you take a scoop of dirt and you pull out two samples of that dirt, they're not going to be the same. They're going to have sticks and rocks and pebbles and maybe a worm. It's not the same. A chocolate chip cookie. So each bite, you may have one bite that just has one chocolate chip, but the other half of your cookie has all of your chocolate chips in it. Granite, that's a rock and that's why everybody loves granite countertops, is because of the quartz within the granite gives it that unique pattern that people really like. So if you look at this, we have matter, this flow chart. The first thing you want to ask yourself when you're analyzing matter, which you're going to do on the next few slides, is does it have a varying composition? Okay, so if it doesn't, that's going to be a sign that you're working with a pure substance. Okay, so and there are, remember, two types of pure substances. We have an element. Remember, elements cannot be broken down into simpler substances, such as helium. If it can be broken down into simpler substances, that's where we're working with a compound, such as pure water. When we're talking about your mixtures, you want to ask yourself, are they uniform throughout? If it's not uniform throughout, then it's heterogeneous. So think of the beach, okay? You have on the beach, you have water and you have wet sand. So these are your water molecules. And then you have your sand in the background here, okay? So it's not the same throughout. If you're looking at tea with sugar, we have your tea, we have your water molecules, and then we also have your sugar compounds here. So it's all uniform. It's the same throughout. So this is if you could look at them microscopically, and that's what we're going to look at in class next week, is we're going to be looking at and analyzing these particle diagrams together, and I'll work with you with that. But for today, we're just going to be looking at the pictures or the names that I give you to help you with classifying what type of substance it is. So what you're going to do is you're going to identify the following. I'm going to have pictures for you to look at, and you're going to make a text box or add a text box, or you can try circling the element, compound, or mixture. Remember, an element is going to contain one type of atom, and that would be any of the elements that make up the periodic table. So you can have your periodic table out to help you. A compound is going to contain two or more different elements that are chemically bonded together. So again, have your periodic table out so you can look at the names, because you may not be familiar with some of the chemical names. And then we have your mixtures that contain two or more different substances that are physically combined, not chemically combined. And mixtures can be made up of elements and compounds. So with mixtures, you can have a mixture of elements, you can have a mixture of compounds, or you can have a mixture of an element and a compound. So keep that in mind. And if you could try, you could also with the mixtures, if you could identify if it's homogeneous or heterogeneous. And then in class, we will go over your identification when I see you next time.